Pereira to be the first guest speaker of the year, invited talk for School of Technology and Computing at CityU. To give you some introduction, Mayana Pereira is a senior data scientist at the AI for Good research lab at Microsoft. And she has worked for about 3.5 years at Microsoft, both as a senior data scientist and data and applied scientist. And before joining Microsoft, Mayana also worked as a data scientist for Infoblox, and she has a very technical background from her undergraduate and master's degree. She studied electrical, electronics, and communications engineering at the University of Brasilia, both completing her bachelor's and master's degree. For information, that is the degree I studied for my undergrad. And Mayana's work focuses on applying machine learning and privacy-preserving techniques to a diverse range of practical problems at Microsoft's AI for Good team. And she is also an active collaborator of OpenDP, an open source project for the differential privacy community to develop general purpose, vetted, usable and scalable tools for differential privacy. And lastly, her works include machine learning and NLP applications to digital safety, cybersecurity, and software security, and applying differential privacy for privacy-preserving data releases. As you can see, she has a lot of background in machine learning, AI, and vast interest in cybersecurity. And today she's going to give us a talk on a topic that's called the intersection of cybersecurity and data science. And let us give Mayana CityU's a warm welcome with a clapping emoji, if possible. Great, Mayana. Yes, thank you. So it's your floor.
Thank you. I think it's I'm allowed to share. Perfect. Let me share my screen if that's okay. And let me start presenting. I think this is okay. Present. Can someone just give me a thumbs up emoji if you can see my screen, if it's okay? Yes. Yes, can you all see my screen, hear me well?
Yes.
Perfect. Awesome. Thank you so much for confirming. So thank you all so much for being here today. I am, like Brian said, I'm Mayana Pereira. I am a data scientist at Microsoft. I've been working at Microsoft's AI for Good research lab for more than 3 years now. And as part of the pillars that AI for Good works on, is we do work in things like sustainability, health, humanitarian action, but we also do some work in cybersecurity and digital safety. And those two, oops, my teams just talked to me. And one of the, and those two pillars, digital safety and cybersecurity, have been pillars that I have actively contributed to this intersection between machine learning and cybersecurity in the past, in my past years at Microsoft, but also outside of Microsoft as well. And I think there are so many interesting things about this intersection of AI and cybersecurity. There are very interesting challenges that, of course, are not only particular to this intersection, but to other intersections as well. But I think that when we talk about cybersecurity projects, they become even more obvious and more clear. So one thing I would like to let you all know is that please interrupt me if you have questions. I'll be more than happy. I'm here to to talk to you guys. So I'll be more than happy to stop and answer questions. So to start with an overview of AI and cybersecurity, what I wanted to start with is let's think about cybersecurity problems that we have nowadays. And let's think about the cybersecurity world without any kind of data science, data analysis, or machine learning solutions. I think we would have a very different landscape. The advances that data science in general, but also machine learning have brought to the cybersecurity area, I think we all can see out there in our email services, in terms of phishing emails. When you think about communications, online communications, we have machine learning actively identifying malicious activities such as botnet communication. But also, there are ways that machine learning and cybersecurity have been used that are not that obvious to all of us. So I have also worked on prevention of security issues by guaranteeing that software is designed and implemented appropriately. So one of the things that machine learning has been leveraged is to use machine learning to identify security bugs in software as software is being developed. And this is something that definitely helps companies, huge companies like Microsoft and others, to make sure that code that goes to production, oops, I apologize, my dog is playing with a noisy toy here. That code that goes to production has not only been reviewed by humans, but there's also a intelligent system that reviews the code that can identify any code, software code flaw, design issue, and etc. So as we think about the ways that machine learning and AI can impact cybersecurity in general, I'd like to talk about the main challenges. And when I talk to data science students, I want to all to think about these main challenges as huge opportunities. Because we have all these challenges, it means that we do have a lot of jobs available for us, which is great. I think this is something we all need. But most importantly, it is a very, okay, I apologize for this. Very sorry for this little interruption. But most importantly, this is a very interesting area to work on. Working on this intersection of data science, AI, and cybersecurity, I think you have a lot of room to be creative, to think outside of the box, and it's a very fun job to work. I always have fun when I come across some of these problems that at first look like it's not going to be solved, but then with time you can get a little bit more creative, and it's very fun. So I'm going to talk about these three main challenges. Sorry. One is the problem complexity. As a data scientist, I see data science problems, as either data science problems that you look at it and the techniques required to solve it might be a little bit more complex than the usual, but there is data available that you also find easily available data with good labels. There are several things that makes the problem itself doable. Most of the time, this is not the case with cybersecurity problems that involves data science, machine learning, and AI. Another challenge that we have that is very particular to cybersecurity problems, data science problems, is that you have to think about adversarial actors. So if you if you see some kind of cybersecurity issue that you want to solve using machine learning and AI, you know that most likely this issue will evolve to something else in a few months or a few years if you're lucky. And your machine learning solution will need to evolve as these actors change the way they attack our systems. And also there's privacy considerations. When we think about cybersecurity and AI, most of the time the data that we have access to solve these problems is customer data, is users data. It has some kind of privacy concern around the data. And being aware that these privacy issues might exist is important because first, you know your limits and you don't do something, you don't end up doing something you should not do. But second, when you understand that there are these privacy considerations, you can prepare yourself better, understand what is available out there in terms of privacy preserving technologies that will allow you to do data analysis, machine learning, and etc. And this is also important to consider. So let's start with problem complexity. So as a data scientist, one of the things that I do when I first start a new project is to ask myself a few questions. And most of the time, these questions are all around the data. So I start a project, and this is usually my list of my top of mind questions. And first question is there enough data? If I have a problem, a cybersecurity problem in front of me, let's think about detecting spam emails. If I have a database with 10 emails, that might be really hard to do. Luckily, in cybersecurity, I don't think that's usually a problem that we'll encounter. So data volume is something that we can easily, data volume is something that we will easily have when it comes to cybersecurity problem. But it's an important question to ask, because you might have huge volumes of data, but if you need to find a specific kind of attack or a specific kind of cybersecurity issue, your data might not be enough. So it's always a good question to ask yourself. And then second question is, how good is the data? Like I just mentioned, you might have a lot of data, but does your data have the characteristics that you need for a specific project or to solve a specific problem? And how good your data also involves understanding if you do have labeled data and how good those labels are. When you're thinking about machine learning, supervised machine learning is always fun to do. Not that unsupervised is not fun, but it requires much more data exploration, way more tuning. It requires a much more careful and crafted kind of project. And supervised machine learning will give you a little bit more flexibility, especially if you're not a subject matter expert yourself. Having labeled data helps a lot. So asking yourself the question, how good is the data? If it has labels, how good the labels are. I have myself worked in projects where we knew that the labels were not all correct. So we had to, one, understand what was the impact of the mislabeling in when creating machine learning models. And once we understood that impact, we could make a choice in either addressing the mislabeling or not. And then I go to another question that is, what are the data usage restrictions? It's very important to understand this, because it's not only can I use my data to analyze the data or not, or can I use this data to train a model or not, but as you're doing your work, can I combine a data set from that comes from customers from one country with a data set from another country? This might seem a question that doesn't make a lot of sense in so many scenarios, but all those questions are very important to make, and it's much better to be safe than sorry. And the final question that I ask myself if I get lots of no's, so if I don't have enough data, if my data is not good, if I have data usage restrictions, I will ask myself, can I generate data in a lab, or can I generate some synthetic data? Can I simulate some data for this specific problem? We know that simulated data or synthetic data are far from being, something that is similar from the real thing, but can be a good start, can be something that could be used in order to start something and then potentially collecting real world data as you go. So this is another question that I like to ask myself as well. So just to give another idea of how complex these cybersecurity problems can be, suppose you have the data, you could have good labels, you have everything's set in place. You have volumes, you have good labels, you have everything. And now you need a way to analyze the data, right? To make sure that you have a solution for your problem. So you analyze, you train a model, or you have some kind of analysis that you want to do something else, or any way you want to deal with this data. One of the things that happens a lot in cybersecurity is that in many cybersecurity projects and problems, understanding where the cybersecurity problem is not understanding if an individual or single instance is malicious or not, or is bad or not. There are so many cases where you're only going to identify if something is bad when you see that there's a lot of similar things like that happening at the same time, that are so similar that they come from a single source, and that single source is most likely malicious. So I'm bringing up here this IRS fraud phony tax return example, because it's a very easy way for us to understand that if we have a model that will identify if a tax return is phony or not, if it's created by a malicious adversary or not, we might not be able to identify which ones are phony if we're looking at only the single instances. So we have a model that looks only at one single tax return and classifies that if that tax return is phony or not. However, when we change a little bit the way we analyze this, and we move a little bit from machine learning to maybe some graph analysis, and we define a graph where each tax return in our graph is a node. And if two nodes, or if two tax returns are very similar, we can say that there is an edge between those two nodes. When we see a click in a graph, or something like a very close to a click, we know that there might be a cluster of tax returns that is worth studying, that can indicate fraud. So when dealing with cybersecurity issues, there's also that different way of analyzing. Maybe the individual users look okay, the behaviors look okay, but when you look at trying to find a pattern or a group that is acting too much alike, most likely that is an indicative of some kind of suspicious behavior. And that is a little bit different from other areas that I have worked on when it comes to applying machine learning to other areas. So I have a feeling that, and this is a feeling because I haven't worked in all other possible areas, but I have a feeling that the problem complexity when it comes to cybersecurity is kind of special. It's a little bit more complex than most areas. And then adversarial actors, another very fun, not so fun thing that we see in cybersecurity projects. So when we think about classical machine learning applications, we make an assumption as soon as we start training a machine learning model that the underlying data distribution is stationary, kind of ish, but we can make that assumption without, that being too much of a crazy assumption. So suppose I have a machine learning model that is classifying pictures of animals, and all we have is cats and dogs. So a machine learning will get as input a picture. It will be either a cat or dog. The model will make a decision, cat or dog. With time, dogs are kind of going to still look the same. They will look the same. Cats will look the same. So it is kind of a stationary problem, the classification of cats and dogs. In cybersecurity, this is not going to happen. A type of attack that happens today, if we can understand how to train a model to identify a specific attack, most likely in 6 months, this attack will be more sophisticated. Not that this attack won't occur any longer, but there will be something more sophisticated happening. And this is because we have this intelligent, adaptive adversary that we're kind of playing against here to identify what is going on. So one of the things that I usually bring to the table when thinking about these projects is the following. We might not be able to predict what is going to happen, but it's very, very, very useful to know where your model flaws are. Understanding well where the inputs can be manipulated in order to evade the correct classification for your model, understanding where in the process we could have a problem, that is very useful. There are a few different ways to do this kind of analysis when it comes to adversarial machine learning. There is a vast literature. This is more cutting edge work, meaning that a lot of this happens either in academia or you're going to see this a lot being talked in companies like Google, Microsoft, Facebook, but this is more of a research area than a day-to-day data science work. But I still feel like that we as data scientists, even if we're not doing research, we should understand that malicious adversaries can manipulate either entries to evade classifiers, or there are some other kinds of manipulations in the training data, depending on how the training data is collected, where the training data is coming from. Those manipulations can also happen there. So as an example here, I brought this example of a email classification, the email classification problem. So you have an email, you're training a model where you want to classify an email as either spam or not spam. When we're training a classifier like this, a linear classifier in this example here, what we do is our model learns a vocabulary of words. For each word, our model will assign a weight. So some words will have a positive weight, some words will have a negative weight. In this example here, the words with negative weights are the words that are more correlated with spam. The words with negative weights are the words less correlated with spam emails or more correlated with non-spam emails. So when we have a new message and we send this message to the model will analyze the words and see if it has more words that correlates with spam or not spam, and make a decision based on those words if it's malicious or not. However, if an adversary kind of has either access to the model, and it doesn't need to be to the model weights at all, just to the model and send a few messages to see the output, even if the adversary doesn't understand what is happening, just a black box of the model, the adversary can start to understand which words in his spam email he can change to make it to make the model classify it as a non-spam email. So this is an example where the adversary adds the word campus and adds a few other modifications in a few words, and a spam email gets classified as, in this case, ham, but non-spam. So we see this all the time in our email inboxes. From time to time, we get a spam email that should not be there, although the spam filtering is working really, really well, but we see some things coming from time to time. And this is because the adversaries get a little bit more sophisticated. They kind of understand what is happening in the model, and it can make these changes. So understanding that this is possible, this will happen, and sometimes just access to the service itself gives the adversary enough information that is good to know if you're working with cybersecurity and machine learning. So now that we've discussed all these nice things about the challenges that projects in AI and cybersecurity in this nice intersection will present, I want to bring a study case that I think illustrates really well all these nice challenges that I brought up. Would like to know, before I move to the study case, if there's any questions that you might have, or should I continue? I'm going to assume that it's all good, because I cannot see the chat. If anyone is asking anything in the chat, I don't have, from my screen, I cannot see it. Nope. Okay. So what I want to show you all here is a problem of the dictionary DGA problem. I'm going to introduce to all of you what is the dictionary DGA problem, because most likely you're not familiar with this specific problem. But I'm going to introduce you what the dictionary DGA problem is and how this specific problem required all these. I mean, this specific problem had all these complexities that I just mentioned, that we many times find in a cybersecurity / ML, the intersection. So before I introduce what is the dictionary DGA problem, I want to explain briefly what is a DGA. So a DGA is an algorithm that is part of a malware. So when a machine gets infected with a malware, there are a few of these malwares that they have a DGA algorithm in that malware. What is a DGA? DGA is a domain generation algorithm. And why does a malware has a DGA inside its code? It's for communication with command and control servers. And why is that important for malwares? So if malware has the IP address of a command and control server hard-coded into its code, what happens is that whoever is able to reverse engineer the malware knows the IP address for the command and control and can easily block that IP address. and no one communicates to it. If the malware has a domain generation algorithm, what will happen is the following. Each day, when the malware wants to communicate with its command and control server, the DGA will create a long list of domains. Those domains, they depend on certain seeds that are usually random and are usually hard to predict. Which seeds are this? Even if you reverse engineer the code, you cannot predict which are the seeds that are going to be used. So once you have the DGA creating this long list of domains, usually the seed is something like date and time or something that is online somewhere, and they have a way to connect to the seed. So it will generate a long list of domains where one of those domains are going to be the correct domain that will communicate, create this communication channel between the infected machine and the command and control server. The other domains, they are just NX domains, so they're not going to resolve. So the infected machine, when they want to communicate with command and control server, they will try all these different domains until one of those domains resolves, and then they create the communication channel. What the cybersecurity community and data scientists as well realized is that these domains, they looked random. They didn't look like natural language. They looked weird. So this is an example of a real DGA domain. And looking at these domains, what the cybersecurity experts and the data scientists realized is that it could be, they thought maybe it's possible to create a machine learning model, an AI solution to detect, identify, and predict which domains are DGA, which domains are not. And they were right. They trained machine learning models, and the machine learning models for DGA domains like this, they work very well. They're extremely precise, super high accuracy. So if you have a machine learning model like this in your network, it will block with a very high precision most of these domains, and you won't have a problem of a malware communicating with a command and control server if your machine is in a network that is secured by this kind of machine learning model. But what I mentioned before is that as soon as we get success, as soon as we are successful as cybersecurity or machine learning, an adversary will come and ruin everything that we thought we had conquered. So, as I mentioned in the beginning, the problem was to differentiate domains that look like this, that look like natural language, from domains that look completely random. Things like a mix of letters and numbers, things that didn't make a lot of sense. Of course, our adversaries got sophisticated, and now we had a different problem to solve. Now the problem that we had in our hands to solve was to differentiate these two kinds of domains, because instead of using an algorithm that generated domains that looked random, now the DGA algorithm used the dictionary and created domains that didn't look random at all. So here in this example, one is a true DGA domain, and one is a domain from an art gallery. And it's just by looking at it, it's really hard to identify as humans which one might be a DGA domain, which one might not be a DGA domain. And this is also a very hard problem for a machine learning problem. Machine learning model. For a machine learning model, this is also a very hard problem. So, yes. So what we did as data scientists was we need to look not at individual instances of these domains, but we need to look at what these domains have in common and how can we leverage that in order to identify those domains in traffic. And this is exactly where we started when we started this problem. So we started looking at things that they had in common. And here we see that many domains here, they have the word hurt in common. And we decided to leverage those words that were in common. What we did is the following. We first started by identifying which words were in each domain. And for that, suppose we have a black box algorithm for finding words, a word finding algorithm. So if we have a domain such as doghouse.com, the word finding algorithm will find the words in the domain. And now we know that that domain has the word dog and house. And now we have this other domain, smarthouse.com. And now we know that we have the words smart and house. So we get our domains, we extract the words, and those words are going to become nodes of a graph. So just like the IRS graph that we each IRS tax return was a node, here we're going to do a variation of that, which is each word is going to be a node in our graph. And those nodes are going to connect if they appear in the same domain. So now we have a mini graph here of our two domains. We have the word smart, we have the word house, we have the word dog. The word house connects to smart because of the domain smarthouse.com. But the word house also connects to dog because of the domain doghouse.com. And when we're analyzing traffic, that's what we did. We got all domains, and then we had our graph, our word graph that came from a domain traffic. And what we did is we analyzed traffic, real traffic, using this graph. What we noticed is that the words from the DGA domains, they were actually connecting very differently in the graph. We could identify those clusters of the malware dictionaries very easily in a graph. And then once we found the malware dictionary, it was very easy to identify in traffic which ones were the DGA domains, the malware domains, and block them. So this is exactly what we did. We got real traffic. We created those graphs, and we were able to identify the malware dictionaries. Oops, sorry. So this is an example of a problem where if we're just building models, we could build neural networks, we could build a combination of convolutional neural networks with RNNs, nothing compared to analyzing the DNS traffic in a way where we could see the relationship between all these domains. And we were very happy to see that a solution. So for identifying these regions in the graph where the malware dictionaries are, what we did is we extracted a few characteristics of these graph clusters. And from these characteristics, such as ratio of edges and nodes, there are also some other very specific graph characteristics that we extracted. We would send this to a classifier, and then the ML would classify the different regions in a graph. So the ML part comes after we build the graph. The ML will classify these regions as either malware related or non-malware related. And the classifier that we used in the end to classify the graph regions was a decision tree, a very simple classifier, but was just enough. I mean, we didn't need anything more than that to be able to identify those malware dictionaries and then go back and block the malware domains in traffic. And then finally, just want to mention briefly the privacy considerations once again. I think one of the hot topics recently in AI is responsible AI. Part of being responsible when you're building AI models is privacy. There are other pillars when we think about responsible AI as well, but privacy is a big pillar in responsible AI. And I think when we're talking about privacy, we need to think about privacy concerns, but we absolutely should not limit ourselves when it comes to preserving privacy. I think one thing that we all as data scientists should understand and should know is that there are privacy enhancing technologies that will enable us to work with data that are, that are potentially violating users or customers' privacy in a way that we still preserve their privacy, but we are getting the insights that are necessary in order to guarantee the security of our customers. So we can guarantee security without violating privacy and making sure that our customers and users, etc., can have both. It's very important. I think that when you're solving a problem, you're not creating another one. Solving a security problem by creating a privacy issue, that's not good, but we are getting to a point where we have a lot of technology available to us, which is great. And some of the takeaways from working for a few years in this interesting, in my opinion, very interesting intersection is between AI and cybersecurity. First one is that data acquisition can be an issue. Good labels can be an issue, but that should not stop you. Keep pushing, keep thinking, simulate some data in a lab or think about some synthetic data, and start small, and then with time acquire more data, gather more data, etc. Data representation and how to tackle a problem can make a huge difference. Not necessarily bringing the big guns is what is going to make you solve a problem with more efficiency and more accurately. Sometimes simpler problems, simpler models, will give you more interpretability, will give you more insights about the problem itself, rather than using super complex neural networks. I'm super fan of the super complex neural networks, but I think there is a time for when they're useful, and in some situations, I think they become a little bit cumbersome. So I think about it when creating your models. Don't forget the adversarial actors, because they do exist, and especially in cybersecurity, in privacy considerations. And that's it for today. Thank you so much.
Okay, thank you, Mayana. That's a great talk. Thank you. Let's give her a round of applause.
I think they did it. Okay. Good time.
Okay, so I think we are, yes, I think we are open for questions, right? So yes, when you ask a question, would you, if possible, would you turn on the camera and use your mic and ask the question, please?
If no one else, I have a quick question. So kind of on the topic of privacy and responsible AI, have you ever run into any specific ethical issues in your work?
No, No, absolutely not. I think this is, when it comes to ethical issues, I think this is one of the things that, and I'm going to say, I cannot say about every single company out there, but at least I think the big companies like Microsoft and Google and etc., they are extremely worried about this. So even when I myself have to deal with Microsoft data, I don't have access to data easily. It's super, super hard. And there are so many steps for so many things. In so many of my projects, I had lawyers reviewing the kind of work that we were interested in doing before anything was approved. So no, not at all. And I think that they're, at least at Microsoft, I feel like they want for people to be actively thinking about these questions. So there are so many, not only internal but external conferences and events where we talk about things like ethics and privacy, and then again fairness, which is also a pillar of responsible AI. And I think that we as data scientists, we also want to make sure that we're doing everything in a very responsible way. So thank God, no, I have never experienced any ethical issues.
Thank you.
Okay. Thank you, Mayana. I don't know I pronounced your name correctly. So my name is Sam Chung. I'm Dean of School of Technology and Computing. So I have some connection with Anderson, but I don't want to talk further. Okay. Yes, I have two questions.
Sure.
First question, cybersecurity also real time is very important.
Oh,
Somebody did something, then you want to catch it. So your research area, how much can support this one in terms of time-wise? Okay, how much rapidly you can grab it? Then second one is a very general question. Here you can see a lot of our students. Okay, somebody they are looking for career in data scientist. Also, you brought the cybersecurity, so you can share the some of experience in terms of a market. It does not have to be Microsoft, but so
Sure.
any company. Okay, so first question, real-time issue. Second one is a career. Yes, thank you.
You're welcome. Thank you for the questions. They're really good. So timing is absolutely important. The work I presented here regarding the DGAs, it was a project. It's publicly available if you have it on Google Dictionary DGA. I have spoken about this specific project many times, but this particular project was done before I joined Microsoft. And one of the things, just to link to the timing, but one of the things that this particular project did was every day we're looking into DNS traffic to find new dictionaries. Because every day you have these things changing a little bit. When I say these things, is the cybersecurity attacks. They change a little bit. So they're very dynamic. So one of the very, very nice characteristics of this specific project is that every day we were looking into new dictionaries and then reviewing traffic and then blocking things. So every day we're running the model to find new malware dictionaries. Timing is a big thing. In other projects, what you could have is more of an anomaly detection model where anything that falls out of the norm will potentially raise a flag and send to either another model. But many, many times what you have is machine learning models looking into traffic. Any anomaly, it might send to a human reviewer. So you have a lot of this important pipeline where ML is responsible for serving data to humans. You still need a lot of human reviewing, especially in critical systems where you want to make sure that nothing is out of the norm or any security issues is happening. When it comes to career, I think if you're not only cybersecurity, but data science in general, there are, I think most of you know, there is a lot of job openings, but at the same time, I understand that there's a lot of competition. I think my first suggestion is one thing that I did, and I always suggest to people I work with or people I talk to and are looking into starting their data science career, think about a project that you really like and try to solve from a data science perspective. So I have a friend that he wanted to explore the map of UW Seattle in terms of accessibility. He made a machine learning model where he did scan where all the ramps for wheelchairs were and which one were the best paths to go from one way to another when you have accessibility issues such as a wheelchair. This was a project that he was interested in. He just made it available on GitHub, and this got him a really nice job. It was one of the things that people that were interviewing him got really interested in. I myself did a lot of volunteering in data science before I got my first job as data scientist. I had a master's not in data science, and I wanted to change careers. So I started volunteer for a few projects, got online, did a few interesting things as well, made it available. So I think that proving that you can solve problems and solve problems in an interesting way, that is definitely a good thing to do.
Thank you so much. That a lot of non-profit organizations, they are looking for the opportunities. Okay, thank you for your tip. Yeah.
Any other questions? Okay, Mayana, thank you. I really find your talk quite fascinating. It's an intersection of all the hot areas that have been highlighted. So, do you have any suggestions for students who are approaching for one area? So, for example, students who are have a training in the data scientist who might not necessarily know super well about cybersecurity, and so yeah, if there's such students, what would be your suggestion?
One of the things that I feel like are always interesting is if you can attend a conference. There are so many interesting conferences that offers a student fee at a very reasonable price. That will give you a feeling of what the industry is doing, who are the industry people, and you can always, and then you can understand if there is a problem that you really like, who is working on that problem. And you can always send an email because now you understand that this specific person is working with a specific problem. And when you go to these talks, people will leave emails. This is a very nice way if you're very passionate about a topic. And this is not only for cybersecurity, so you can think about data science applied to marketing. There are probably interesting conferences out there, or data science applied to the other thing I work with sometimes is AI for good. So if you like data science applied to sustainability, you go to these talks, think about the topics you really like, and then ask good, interesting questions to the presenter. And then you're under the radar, It's something that you can start building interesting connections and relationships if you know how to leverage it.
Great. Thank you. That's a very good advice. Would you, on top of your head, do you have some conferences that students can, try?
Sure. RSA is a really big one and very, very famous. I met a lot of interesting people there. I got my Microsoft job because of RSA, so I really like that one. There are a few interesting local Seattle conferences in the cybersecurity intersection with machine learning, but not only that, but cybersecurity only. I did go to one that was called DefendCon. It sounds like DAFCON, which is another big conference in the area, but DefendCon is in Seattle every year. I don't know how they're operating now during the pandemic, but I know that it happens every year. It's very nice, DefendCon, because it focuses on minority groups. So for women that might feel a little bit intimidating going to this conferences, DefendCon is awesome. I had a wonderful time a few years ago. For other areas, I can think about a list and send to you later.
Thank you very much.
You're
Great.
welcome.
Brian, I have a follow-up question. So
Sure.
also one of them nowadays, Microsoft Azure, they have a lot of certifications, even including machine learning. How about your view about those certifications from Microsoft Azure? Yeah.
I think they're always amazing because that gives you a piece of paper that proves that you are familiar with those tools. You are familiar with certain tools that are very useful in many companies. So absolutely good. That's not going to hurt. But I would, on top of that, add something to show what is different about you. So think about an interesting project and have it available on GitHub. Think about what is interesting about you, your point of view for something that is a killer.
Okay, thank you. Thank you. Our student, then they can start the capstone project prep earlier. Also, do not forget, some of them already sent one LinkedIn invitation you may get, okay?
Awesome. Fantastic.
Thank you.
Great. Students already, looking for the websites and they are, sharing over here.
Perfect. Yes.
Great. Thank you. Yeah, are there any other questions? If not, would it be possible to have a kind of a group photo at the virtual setting? So whoever feel comfortable sharing, turning on your camera, let's have a group photo. Amanda, would you arrange this one, please?
Yeah.
Also, Brian, announce the next invited talk.
Yes. So I'll do that after this one. Okay. Sure. Actually, I'll do that. So just for information, we had a great talk by Mayana Pereira today. And in Module 5 on February 10th, 2022, we'll have the second talk, which will be on the professional career preparation by Yun Chung and Kwan Peng. These people are software engineers at Microsoft and Google. So, yep, please keep your interests. Okay. So, yep, Amanda, would you? So
everybody turn on camera if you can. Don't be shy. I can see the new face here as Mari and Don and Winter also. I can see that. Yes, Catherine. Okay. Persevere. Yes, welcome. Yeah. Okay.
Great.
Okay, all other people very shy or they are sleeping now. Let's take a photo. Yeah.
Okay, if we're ready, then I'll take the picture in 3, 2, 1.
Oh, Morgan, you're right. One more time.
Okay, we'll do it again.
One more time.
Okay, 3, 2, 1. Okay, let's see.
Let's see what it looks like.
Great. Thank you.
Okay, there's the uncropped version in the chat.
Okay, that's great.
Fantastic.
Okay. Now, Brian, you can close it. Yeah.
Sure. Thank you again, Mayana. It was such a pleasure, and I hope you enjoyed being here as well. And I hope that we can have a CityU connection in the future.
Oh, absolutely! This was awesome. Thank you so much for having me.
Thank you.
Bye.
Thank you so much. Bye bye. Yeah, Jerome, thank you for coming. Yeah.
Bye.